test that you guys just took. The first question starts with this diagram right here. Now this diagram is talking about your rational numbers unit. And you guys started learning this in 6th grade, especially the things that are on this particular diagram. Now the way that you usually see it is not how it's written right there. You usually see it written more like this, where you have rational numbers, and then what comes after rational numbers? Integers, and then your whole numbers. Now, rational numbers are your fractions and your decimals. Integers are your negative whole numbers. And then natural numbers, yeah, that goes there right there. Whole numbers is just 0. But when natural numbers aren't on there, then it's the 0, 1, 2, 3. So this diagram right here, because natural numbers is not included, this right here is whole numbers. And then in your natural numbers is 1, 2, and 3, and so on and so forth, like that. Okay. So this right here is section B, which is integers. And we just said that integers are your negative numbers with no fractions or decimals. Now, if we look, A has a fraction and a decimal. B has a fraction and a decimal. Now, see, this is supposed to be a negative. So it's -7, -8, and -4, which is an integer because integers are your negative numbers with no decimals or fractions. This one says, which representation does not describe the relationships between subsets of real numbers? Now, real numbers is what we started covering this year. It includes everything we just learned in 7th grade and in 6th grade, and then it starts including irrational. So the way it looks is you have this bubble over here, which are your rational numbers, and then you have this bubble over here, which is your irrational numbers. And those are all by themselves. And then rational are over here. Now, of rational numbers, there are several subsets of rational numbers. So the first one is what we just talked about with the integers. And then the next one is whole numbers. And the next one is natural numbers. So when we take a look at this, we're looking for the one that doesn't look anything like this at all. Like rational and irrational may be together, or integer and whole numbers may be separate from each other even though they're stacked into each other. So that's what we're looking for, is something that doesn't look like that. When we look at this right here, real numbers, okay, that's fine. Real numbers have rational numbers. Well, that's true because the real numbers have the rational numbers up here. But then we see integers and counting numbers. Now, if we look up here, integers and counting numbers are inside of each other. Okay, so your counting numbers should be actually right here within the integer bubble, not over here. So that's why this one is incorrect. But I'm going to go through the rest and talk about why they are correct. The most common one that I saw picked was this one. Y'all, this is exactly what this is right here. You have your rational on this side, you have your irrational over here on this side. Then you have integers, then you have whole numbers, then you have counting numbers. And just like that, here you have rational, then you have integer, then you have whole numbers, and then you have natural. That is the correct diagram. This one right here is just kind of like this one up here. Your rational numbers and your irrational numbers are separated. So this one's correct. And then this one, it goes integer, whole, natural. Just like it does up here where it goes integer, whole, natural. So the only one that it could be would be A. This one says, which number line shows a point that best represents the value of the square root of 250? So we're going to put into our calculator the square root of 215. And that gives us 14.662. That means it comes after 14.5 and before 15. So if we look here, this is right smack dab on 14. Well, this is 14.662, so it can't be right smack dab on 14. This comes after 14 and before 15, so that one could be it. This one comes it comes between 14 and 15, and it's a little bit closer to the 15s this time, so that one could be it. And then this one is smack dab on 15, which that's definitely not it. So now we have to take a look. Okay, my number is 14.662. Well, what is 14 closer to? 14 or 15? 14.6 is over that halfway mark between 14 and 15. Here's the halfway mark of 14.5. 14.6 lies beyond that. So it should be closer to the 15, which would be this one. All right, this one says, between which two consecutive integers on the number line is the square root of 17? So we're going to put into our calculator the square root of 17, and we find that it is 4.1. Well, 4.1 on a number line falls between 4 and 5, really close to that 4. So it's between 4 and 5. A researcher measured approximately 0.005123 grams of bacteria in a sample. How is this number represented in scientific notation? So I'm going to write this really, really big right here. Now, scientific notation is where you have blank times 10 to the blank. Now, the first thing we need to talk about is our exponent. I have a decimal right here, so since I have a decimal, is my exponent going to be positive or negative? Because we have an exponent, because we have a decimal, our exponent will be negative. Then we need to see how many times we move our decimal. Well, we know that our decimal needs to go between the first number and the second number. That is a non-zero number. Well, the first number that I see that is a non-zero number is 5. And then the second one that I see is 1. And it needs to go between that. So that's going to be 5.123. Well, how many over does that need to move? 1, 2, 3 numbers over. So it's -3. Or you could do your loopies. That works too. And you could do 1, 2, 3 numbers over just like that. Either way. So you should have gotten B. This one says a microscopic cell measures 3.8 times 10 to the -4 centimeters in diameter. What is this number in standard notation? So that's where we take it out of scientific and put it into a normal number. Now, because this is negative, our final answer is going to be a decimal or a whole number. This is going to be a decimal, so we can automatically X that one out. Then I'm going to move my decimal over 4 times. 1, 2, 3, 4. My decimal moves to right there, and then we have 0, 0, 0. So we should have 3 total zeros in our answer. Well, the only one with 3 total zeros is this one right here. The next one said Robert and Dora need to write 4 billion, 3 million using scientific notation. Robert wrote it like that, and Dora wrote it like that. Which one is correct? So we need to, I'm going to go ahead and just turn this into scientific notation myself. So I'm going to rewrite the number. My decimal goes on to the end of it. I know that I need it to go between the first and the second number, so my decimal needs to move here. Well, before that, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Or you can move it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Either way. So we know that the one that has an exponent of 9 is going to be correct since we moved it 9 times. Well, Dora is the one that wrote it with the exponent of 9. So we can cross out both Roberts. Leaves us the B and C. The first one says Dora is correct because when converting 4 billion, 3 million, the decimal would be located between the 4 and the 3, and the original decimal point in the standard form moves to the left 9 places. Hey, isn't that what we just did? We just moved it to the left 9 places. That sounds good. The next one says Dora is correct because when converting 4 billion, 3 million, the decimal will be located between the 4 and the 3, and the power of 10 is always the number of zeros plus 1. That is wrong. Remember, we talked about how we do not count zeros at all. So that's B. The next one says the area of a piece of land is 4,951,000 square meters. How is this number written in scientific notation? So remember, scientific notation is where we do blank times blank to the blank. Now, this is a whole number right here, so is that going to be positive or negative? My exponent will be positive in this case. So now all we have to do is just move our decimal. Our decimal starts here, and we know that we want it to be between that first number and that second number. So we want to move it right here. So that gives us 4.951. And then I told you all to use the dot. So dot or times 10 to the. Then we have to see how many times we moved it. Well, between my two decimals, there are 1, 2, 3, 4, 5, 6 numbers. Or you could have moved it 1, 2, 3, 4, 5, 6 times. This one says, which list shows the numbers ordered in ascending order? Now, ascending means going up, so that means from least to greatest. So we're going to put our numbers into our calculator. So for this one, we have -2, and then we have 3/8. So we do 3 divided by 8, and that's 0.375. Then we have -8.5. That's going to stay exactly as it is. And then 4/3, we do 4 divided by 3, and that gives us 1.333. 140%, we take our decimal and we move it 2 places to the left, so that gives us 1.400. Then we have -8/6, so I would do -8 divided by 6, and that gives us -1.333. And then we have 0.8. What we need to do is we first, since it's going from least to greatest, we know that our negative numbers are our least numbers. So anything that does not start with a negative number is not going to be our answer. Then we take a look at our answers and we see -2 and 3/8 and we see -0.85. We need to figure out which one is more negative. -2 and 3/8 is right here, and -0.85 is right here. Now remember, the more negative a number is, the smaller it is. So the more negative number is -2 and 3/8. So that one is going to be one of our correct answers. Now we have two -2 and 3/8, so we just eliminated D. Now, when I take a look at my next things, I have 140% and -8/6. Obviously, -8/6 is smaller than 140% because this right here is a positive and this right here is a negative. We go with our negative because that is smaller. So the answer is C. This one says, Sam was asked to place the numbers shown below from least to greatest. What number would Sam have in the 5th position? So I'm going to go 1, 2, 3, 4, 5 positions. And we're going to turn all of these into decimals. So we have 1/3. We do 1 divided by 3 in the calculator, and that gives us 0.333. Then we have -0.5, so I'm just going to rewrite that as -0.500. Then we have the square root of 3, which we'll rewrite as 1.732. Then we have 9 divided by 7, which gives us 1.285. 350%, we take the decimal and move it over twice, and that gives us 3.5. Then we have -1 and 3/4, which gives us -1 and 0.75. Pi is 3.141. 4.7 is 4.700. This would be -0.666. And this would be 1.222. So when we start placing these in order from least to greatest, the more negative they are, the smaller they are. So I'm going to look at my negative numbers first. I have 3 negative numbers. The more negative it is, the smaller it is. So the most negative number is -1.75, which is -1 and 3/4. Cross it off. Then after that, we have -0.6666 because the 6 is bigger than the 5, so that means it's more negative. So we have -0.66 repeating. And then after that, we would have -0.5. So that eliminates all of those numbers that are right there. So the next thing I'm going to look at are my next smallest numbers. So we're going to look at the decimals first. This one has no whole number. This has a 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 whole number. And that has a whole number. The only one that doesn't have a whole number is 1/3. So that's the next smallest one. And then after that, we take a look at our whole numbers. We have a whole number of a 1 right here. A whole number of a 1 right here. We have a whole number of a 3 right there. That's bigger than the ones. Then we have a whole number of a 3 right here. That's bigger than the ones. We have a whole number of a 4 right here. That's bigger than the ones. We have a whole number of a 1 right here. So now we compare our ones with the whole number of 1. This is a 7. This is a 2. The 7 is too big to be next. By the way, I'm crossing these out because it asks for the 5th position, and that is the position that we're on right now, is the 5th position. So I don't care about placing these fully in order. So then I take a look. I have 1.2, and then I have 1.2. So we take a look at our hundredths place, and this has an 8, and that has a 2. So the smaller one would be 1.22 repeating, which is A.